Okay, just start. So, it's a common perception that, you know, when an astronomer goes to the telescope, that he uses his eye, or that, you know, some sort of interface with, you know, seeing is involved. But actually, at the telescope, the really important thing is to build a sophisticated light detection device, because everything we know about the universe comes from the light we see from the stars or the galaxies or the planets that can be studied in sort of, you know, various parts of the universe, from things nearby in our own Milky Way, which the planet Earth is in, to the most distant galaxies that we can see in the universe. And so in order to figure out what processes influenced the formation of the Earth, the formation of the Sun, the formation of our own galaxy, the Milky Way, we need instruments to analyze the light. So one of the important things we do at my institute, JEPI, is we build instruments that then go on large optical telescopes. So what I mean by large optical telescopes is, I mean telescopes that see the light that your eye sees, and maybe a little bit more to the infrared, which is like the heat that gets generated, say, from your body, is infrared photons, infrared light. And so those telescopes can see that kind of radiation, those kinds of photons. So one project I'm involved in is to build an instrument for the next generation of large optical ground-based telescopes. So we currently have what's called the Very Large Telescope, which is 4 telescopes in Chile with mirrors that are 8 meters in diameter. So the important part of the size of the telescope is that we study objects that are very faint and they emit photons. And the bigger the mirror that you have to reflect those photons into your instrument, the more photons you collect. And remember, light's composed of photons, little particles. So when we want to see fainter objects, we need a bigger telescope. So this instrument is called Eagle, of all things, like the bird, is for what now is a 42-meter diameter telescope. And so that's the big mirror, the primary mirror, that then collects the photons from the faint objects. So we want to go from an 8-meter mirror, which is the largest one we have access to in Europe, to 42 meters. So it's getting very big. And so the instrument that I'm what's called the project scientist for, which means I figure out all the science, you know, the types of objects that, you know, this instrument should be able to study, and what the implications will be when you study these objects. And then you develop what's called the science case, which is you write all this down. You know, if we build this instrument, this is what we should learn. And so Eagle is a very interesting instrument because when you look up at the night sky and you see the stars twinkling, for astronomy that's bad, because the atmosphere has waves in it. And as these waves pass through, it turns out it changes the direction of the photons. They move in slightly different directions. And so when you look and you see the star twinkling and moving, that's bad, because what happens there is it means that a star should be very small, point-like a pin. But when you pass the light through the atmosphere, suddenly it gets like a big pin. It grows. We don't like that, because what we want to do is we want to see the smallest things you can see. So that's called resolution. Being able to increase the resolution means to take something that, you know, you can't see very well, and then you shrink it down so that the atmosphere doesn't blur the image anymore. It's sort of like if you had